Hey everyone, welcome back to Share Science, the weekly science brief, the show where we dig into the week's biggest science stories and make them actually make sense. I'm Curie.
And I'm Derek. And Curie, I have to say, this week's lineup might be the most cosmically humbling set of stories we've ever covered. We have new evidence that tiny ghostly particles called neutrinos may be the reason you and I exist at all. We have official confirmation that a so-called city-killer asteroid is not going to hit Earth. We have bacteria that can survive being launched off a planet by an asteroid impact, which has real implications for whether life could travel between worlds. We have a discovery that completely rewrites where the Milky Way sits in the universe. And we have a TRex that turns out to have had a much slower, stranger childhood than anyone imagined.
What a great lineup. Let's get into it. Okay, so get this. Billions of neutrinos are passing through your body right now, and they might just hold the answer to why the universe exists at all. That's where we're starting today. An international team of physicists has combined data from two major neutrino experiments, and the results give us the strongest evidence yet for why matter survived the Big Bang. And by matter, I mean everything. Every atom, every star, every planet, you, me, the microphone.
All right, let's break this down. Why is this even a question? Why wouldn't matter just exist after the Big Bang?
Great question. So, according to our best understanding of physics, the Big Bang should have created equal amounts of matter and antimatter. And here's the thing. When matter and antimatter meet, they annihilate each other completely, leaving behind nothing but energy. If there were equal amounts, they should have canceled each other out entirely. No atoms, no stars, no galaxies, just light and energy.
But obviously that's not what happened. We're here, so something tipped the scales.
Exactly. Somewhere in the physics, there must be an asymmetry, some tiny difference in how matter and antimatter behave. That tiny imbalance is what allowed a small surplus of matter to survive. And that surplus is literally everything we see in the universe today.
So where do neutrinos come into this?
Neutrinos are these incredibly strange particles. They're so light they might even be massless, and they barely interact with anything. Billions of them are streaming through you right now from the sun, and you wouldn't even notice. But here's the key. Neutrinos have antimatter counterparts called antineutrinos. And physicists have suspected for a long time that neutrinos and antineutrinos might not behave as perfect mirror images of each other. This is called CP violation.
And the new experiments show evidence of this?
They do. The experiments, T2K in Japan and NOVA in the US, showed that neutrinos and antineutrinos oscillate, or change flavors, at slightly different rates. That difference is the kind of asymmetry that could explain why matter survived the Big Bang. It's not definitive proof yet, but it's the strongest evidence we've ever had.
So if this holds up, we're talking about uncovering the mechanism behind the existence of everything. That's huge.
It really is. This is one of the deepest questions in physics, and we're getting closer to an answer. If you want to dig deeper, search Neutrino CP violation 2026, or look up the T2K and NOVA experiments.
All right, let's move on to story 2, which I think will be a relief for a lot of people. NASA has officially ruled out any chance of the asteroid 2024 YR4 hitting Earth or the Moon in 2032.
And they confirmed it using the James Webb Space Telescope, which is about as definitive as it gets.
Let's give some context here. Earlier this year, 2024 YR4 caused a bit of a stir when initial calculations showed a 3% chance of it hitting Earth. That might not sound like much, but for a newly discovered asteroid, that's unusually high. It was enough to get planetary defense teams around the world paying very close attention.
And for good reason. This asteroid is estimated to be between 40 and 90 meters across. That's in the same range as the object that caused the Tunguska event in 1908, which flattened 2,000 square kilometers of Siberian forest. A direct hit on a populated area would be catastrophic, hence the nickname City Killer.
So NASA pointed the James Webb Space Telescope at it, and the updated calculations showed zero chance of impact. It's going to pass Earth at a safe distance in 2032.
Which is still exciting from a scientific perspective. It'll be close enough to study in detail, but not close enough to ruin anyone's day. And what I love about this story is that it shows the planetary defense system working exactly as it should. Object detected, flagged, studied, and ruled out as a threat.
And we're so much better at this than we were even a couple of decades ago. The combination of survey telescopes scanning the sky and tools like Webb for precision measurements, it's an incredible capability. If you're curious, search 2024 YR4 Asteroid Update 2026 for the full trajectory analysis.
Story 3 takes us to the question of whether life could spread between planets. This week, researchers published results on a bacterium called Dinococcus radiodurans, and what it can survive is absolutely mind-blowing.
I've heard of this one. It's famous for being ridiculously tough.
That's right. Dinococcus radiodurans is already known as the world's most radiation-resistant organism. It can survive doses of radiation thousands of times higher than what would kill a human. But this week's research pushed it even further. Scientists subjected it to pressures simulating the shock wave of a massive asteroid impact on Mars, and it survived.
So this ties into the idea of panspermia, right? The hypothesis that life could travel between planets inside rocks?
Exactly. The idea is that a large asteroid or comet hits a planet with life, ejecting rocks into space. Over millions of years, those rocks could drift through space and potentially land on another planet. The question is whether anything alive could survive that journey.
And surviving the impact pressure is just one part of the challenge. There's also the radiation exposure in space, the freezing vacuum, and the heat of re-entry.
Right, but this research shows that Dinococcus can handle the impact shock stage, which is a big piece of the puzzle. It doesn't prove that life has traveled between planets, but it makes the idea more plausible. And it raises fascinating questions about whether Earth life could have seeded Mars, or vice versa. We might all be Martians. Search Dinococcus panspermia 2026 to read the full study.
Story 4 zooms way out, to the large-scale structure of the universe. Astronomers have published simulations that explain why many nearby galaxies are moving away from us faster than expected. And the answer is that the Milky Way is sitting inside a gigantic flat sheet of matter.
A cosmic sheet. That's such a cool visual. So, what's happening here?
The Milky Way, along with our local group of galaxies, is embedded in this vast, flat structure of matter. Surrounding this sheet are enormous voids, regions of space that are nearly empty. These voids act like low-pressure zones, pulling matter, including galaxies, toward the edges of the sheet.
So the galaxies near us aren't being pushed away from us specifically. They're being pulled toward the edges of these voids.
Exactly. It's a beautiful example of how the large-scale structure of the universe shapes everything, even the local motions of galaxies. And it's a reminder that the Milky Way is just one small part of a much larger cosmic web. Search Milky Way Cosmic Sheet 2026 to see some of the visualizations. They're stunning. All right, last story. And we're closing with a dinosaur, specifically TRex. New research has revealed that TRex had a much slower and stranger childhood than we thought.
This is so fascinating. Researchers analyzed growth rings in fossilized bones and found that TRex took much longer to reach full size than previously estimated.
How much longer are we talking?
Previous models suggested a rapid teenage growth spurt, but the new data shows that growth was more gradual, potentially lasting into the late 20s or even 30s. This changes how we think about T-Rex at different life stages.
And it raises questions about their behavior, ecology, and even parental care. A longer juvenile period usually means more vulnerability, which could imply parental investment or other survival strategies.
Absolutely. It also adds nuance to debates about whether smaller tyrannosaur fossils represent separate species or just juveniles. If growth was slower, the intermediate forms would look quite different from adults. Search T-Rex growth rate 2026 for more on this.
That's 5 stories for the week. We explored why anything exists, confirmed an asteroid won't hit us, met a bacterium that might survive interplanetary travel, learned about the Milky Way's cosmic sheet, and uncovered new insights into T-Rex's childhood.
Science keeps surprising us. Every answer opens up new questions, and that's what makes it so exciting. Until next week, stay curious, everyone.